In this video, we're going to work through the following problem. It says find the polar coordinates of a point with Cartesian coordinates minus 7 square root 2 over 2, minus 7 square root 2 over 2, where r is greater than 0 and theta is in between 0 and 2 pi. Okay, so we want to convert this, right, into polar coordinates. These are Cartesian coordinates, so this would be my value for x, and this would be my value for y. So the equations that we're going to be using, right, are r squared equals x squared plus y squared, and tan theta equals y over x. All right, if those don't look familiar to you, or you not sure where those came from, then you need to watch the previous video where I talk about the origin of these formulas here and the reason for using those. Okay, so next up, right, we're going to go ahead and calculate r. So we would know that r squared equals minus 7 square root 2 over 2 plus minus 7 square root 2 over 2 squared, like so. All right, we're going to go ahead and simplify that out as much as possible. And so when we're squaring a fraction, we square the tops and the bottoms, right? So the bottom part squared would be 4 in this case. And we need to square the top, which is minus 7 square roots of 2. In order to square that, right, we would need to square the negative 7. So negative 7 times negative 7 would be positive 49. And square root 2 squared would be just 2. Okay. All right. Next up, I need to square this, and we know that that is going to be exactly the same. All right, and we need to keep simplifying. You might notice a shortcut here, but I guess I'm just going to go ahead and do that the long way. 49 times 2, right, would be 98. And same thing over here. 49 times 2 is 98 over 4. And then when I add those together, right, I get 196, right, over 4. Okay. And then I need to reduce this as much as possible, right? If you check to see if 196 is divisible by 4, it is, right? It goes in 49 times, okay? And so, you know, you can just use your calculator to check that out and reduce that. The shortcut being, right, that I had 2 49s here, 2 49s here. If I add those together, that's 4 49s. So divide that by 4, you just get 49. Okay, but you know, a lot of times it won't work out like that. So you just, you know, I just kind of went through this the longer way to show you how that went. All right, so now to solve for r, I'm going to need to square root both sides. There are 2 solutions to that, right? Plus and minus the square root of 49. In other words, plus or minus 7. Okay. And however, though, so in general, there would be 2 values that you could choose for r. But in our problem, they did say, hey, let's use an r of a positive r, right? So in that case, we will stick with r equals 7 on this one. It's not like there's anything wrong with the negative, but they just told us to do that. In a previous video, I mentioned the reason why these are given sometimes is so that you will come up with a unique answer. And in previous videos, I talked about, you know, the fact that polar coordinate representations of points are not unique. So there are, in fact, infinitely many possible ones. And so this will just limit the choices, right, for you, and enough to where you will come up with a unique answer. Okay, next up is the value for tangent, or for theta rather, right? So we go with tan theta equals y over x. So that would be tan theta equals minus 7 square roots of 2 over 2 over, and x is also minus 7 square roots of 2 over 2. Okay. So that is going to wind up to be 1. Okay. Because it's exactly the same number on top as it is on the bottom, and they're not 0, right? So that comes out to be a 1. However, I will kind of just work through how you would simplify that, because in some of the other problems, you'll probably have to do that. So here I'm dividing two fractions, right? So if I'm dividing two fractions, one way to deal with that is to invert the bottom the bottom fraction, and change it to multiplication, right? So that would be minus 7 square roots of 2 over 2 times, instead of division, and then invert this, right? So that would be 2 over minus 7 square roots of 2, like so. All right, and then you can see here you would simplify as much as possible. So this, and this all cancel each other out, right, in this particular problem. So you would wind up with a 1. In other problems, it might not do that. You might be left with something here. So, okay, so we get that the tangent of theta equals 1, okay? And so what we're after, right, is the value for theta. There are, in fact, infinitely many values for theta, right, that where you would get tan theta equals 1, all right? And so what we're going to do, right, is to look at the unit circle, right? This unit circle, if you haven't seen this, I talked about it in the previous video, but here I just listed the value of the tangent out next to the point to make it a little easier to look at in these problems. All right, and so we're going to take a walk around the unit circle and find a value for theta that gives us a tangent of 1, right? And so here you can see there's 1 right here, but there's also another one, right? If you follow these values down here. So there's 1 down here in the third quadrant, okay? And that's it for these. So the question is, which one should you pick, right? Should you pick this one or this one, okay? If I look at the restrictions on the value for theta, they say, hey, theta has to be between 0 and 2 pi. Well, both of these are between 0 and 2 pi. Pi over 4 is, right? And so is 5 pi over 4. So how do you choose which one it is? And to choose which one it is, you have to take this original point into account, all right? So to me, it helps to draw a little picture of the situation. It doesn't have to be exact, but it's going to tell you which value for theta that we're going to need, right? And so if I just draw where this point would be in the rectangular coordinate system, right, with x and y right here, I see, hey, x is negative, right? So the value for x, I would go to the left, right? And then the y is negative, right? And so I would go down. So that point that we're looking at, the point that we were given, right, is somewhere down in this third quadrant down here. And again, you don't have to locate it exactly, right? But that's where it would be, because both of these coordinates are negative. So now that we know that our point is down here in the third quadrant, there is one clear choice, right? Going back to our unit circle, right, we see that the value down here in the third quadrant, where our point is located, right, is 5 pi over 4. So the value for theta that we are going to use is theta equals 5 pi over 4, okay? So you always need to keep in mind where that point is located when you are choosing the value off of the unit circle, okay? In this problem, we were wound up with a value for tangent that did correspond to one of the points on the unit circle, so we were able to use this unit circle to do that. In other problems, you may wind up with a value for the tangent that is not on the unit circle, and so therefore you in that case you would have to use a calculator to find the value. But we will talk about that in later videos. So right? The polar coordinate representation, right, subject to those conditions that they asked us to observe, right? In other words, that the r be greater than 0 and the value for theta be between 0 and 2 pi. So the answer here would be 7 comma 5 pi over 4.